Hello, and welcome to today's presentation. Today we're going to be taking a brief look at a LightWave server and a demonstration of the product's capabilities. If you haven't viewed it already, I suggest that you first take a look at the LightWave server quick overview available on the NuWave YouTube channel. Jumping right in, NuWave develops two LightWave products, LightWave Server being server-side middleware, which allows you to expose your non-stop applications securely as REST services, and also LightWave Client, which is client-side middleware, allowing your non-stop applications to easily access REST services from the non-stop. Looking in a little bit more detail at LightWave Server and a brief architectural overview, here you can see LightWave Server resident on the non-stop server. On the left-hand side of the diagram, we have a variety of REST clients that are coming into the non-stop over JSON and HTTP, JSON being JavaScript object notation. LightWave Server receives those incoming requests and via its configuration translates them into an interprocess message which is sent to the backend application, be it a pathway server or a Guardian or OSS process or an application like Base24 or Connex. The backend application processes the request and returns a response back in IPM format, which LightWave Server is configured to convert back into a JSON response over HTTP and return back to the REST client. And we're going to take a look at how that works in a little more detail now. Before we get into the demo itself, it's important to explain a little bit about how REST works. REST is built on the concept of resources, and really anything can be a resource, and it depends on the application, but there are some examples of possible resources listed on the screen here. Once you have your resources defined, you can then start to build URIs, or Universal Resource Identifiers. The URIs are important because they allow us to determine what sorts of transactions are available on the REST interface. So here you see some sample URIs, /customer/1234, maybe a URI that identifies customer ID 1234, and account /456/order, maybe a collection of orders for the account ID 456, and so on. Again, dependent on the application. Once you've got URIs determined, you can then add in the HTTP method to allow you to build CRUD operations, CRUD being short for create, read, update, and delete. So for instance, an HTTP post against the URI/employee may create a new employee with a server assigned ID. An HTTP put may update the details for employee number 1234, and so on. Okay, so getting into the demo itself, once we have our application, in this case a pathway server, REST enabled using LightWave Server, we can access it from a variety of different mechanisms. And today we're going to look at accessing that REST service from both a browser and also an Amazon Echo. Okay, so just flicking over to the sample application, which we can now see. We start from scratch here. First thing we can do is we click Get Employees, and we see a list of employees returned. And also we can see the REST request and the response that was involved in this particular transaction. So the client sent a GET request with the URI of /employees, and that's the entire request. Very, very simple, very straightforward using REST. And then here we see the JSON response that's come back. And via a simple JavaScript client running in the browser, we have that data presented as a table, nicely formatted. We can now add a new employee. We can click Create, and we see the HTTP post and the response coming back indicating the employee has been created successfully. And there it is, employee number 147. So now we can go to our Amazon Echo and issue some voice commands against the same database and the same REST service and see what we get back. Alexa, ask employee server to list employees.
There are 4 employees. The first 3 employee numbers are 3, 100, and 109. Say an employee number.
147.
Employee 147 is Andrew Price, residing at 123 Main Street, Melbourne, Virgin Islands, 12121. Try another employee number.
So there you can see the employee that we just added being accessed by the voice command from the Amazon Echo, and the data being returned in that voice command. Okay, so this is a very quick view of how the LightWave server is configured and built. We take the DDL from the backend application, run it through the LightWave server console. From that, we get sample JSON and Swagger definitions that the client developer is able to use. And we also build the LightWave file system that controls the mapping of messages to and from JSON and into IPM. So that's all done at design time. And then at runtime, we have our REST client sending a request in. LightWave server consults the LightWave file system to understand how to convert the JSON message, converts it into an interprocess message, sends it to the backend server, who replies back, and LightWave server is able to convert that response into a JSON response, which goes back to the REST client. That is our demo for today. Brief and to the point. If you do have any further questions, please consult our website. You can find our documentation listed there as well, or by all means, please feel free to send me a request for any additional information using the information on your screen. Thank you for your time.